Welcome to the next video. Um, we have been talking about different ways to modularize our code. Good code is modular code for many different reasons. As we've discussed previously, as your projects get bigger and more sophisticated, and as you work on teams of developers where you may have a dozen or more different people coding on a single project. It helps to be able to break it up into distinct pieces, pieces that fit together in a modular fashion, like Legos, like building blocks, like bricks that we can lay one upon the other. And we talked about two different ways of modularizing our code. One was functions. With a function, we can take a well-defined to-do list, a recipe, and we can define it, and then later we can invoke that function and call that to-do list into action. And that can save us code. If we write it into a function, we could call it 1,000 times. And each time we get to reuse that code, we don't have to reinvent the wheel. So functions was the first thing that we talked about. The second structure that we talked about for modularizing our code was classes. Classes is an enhancement, an extension of the idea of a function. Unlike a function, a class combines not just data members, what something is, but it also has member methods. So data members, member methods. A class encapsulates, okay, a real world object. It's a way to model a real world object. So a class contains what an object is and what an object has, its data members, as well as what an object does, all right, its member methods. Um, Classes are a wonderful enhancement and a tool for modularizing code. Well, in this video, we're going to talk about a third option, and that is putting your code into modules. And this might be the shortest Python video I've ever created. We'll see. But extending the idea of functions and classes, you can put your code into modules, okay? And in several projects that I've posted, I've put all my code into one Py file. I have a couple of projects that are over 5,000 lines, one that's like 6,500 lines of code, and I put it into one Py file. So I could upload it to GitHub, and that way you can click on the link and it'll just display the code in a nice, neat format, and you won't have to worry about clicking multiple files. That's great if you're doing a tutorial project or a project where you want to display code on GitHub. But if you're actually working on a project with multiple people, you don't want to put 6,000 lines of code in one file. No. It's better to break it up. And the same way you break your code up into functions and take your objects and code them into separate classes and an inheritance hierarchy, you would also put your code into modules. And a module, it's a great way to organize your code and break it up. It's just a Py file that you write and that you save. And then you take that Py file and you import it and include it in another Py file. You include it as a module. And so it becomes a way to sort of take your code and organize it. And the way I would do, if I weren't putting it all in one file to display on GitHub, the way I would do those larger projects, I would take my inheritance hierarchy, my classes, and I'd put them in one module. And I might take my functions, my external functions that manipulate those objects and put them in another module. And then I might take my interface and put it in a third module. And then I might have a fourth Py file that's sort of my master control script. And it would import and load those other three modules. And then from that, I would import and get my classes and import and get my external functions and import and get my GUI, my Tkinter graphical interface, and so forth. So that's what we're going to take a look at doing here. It's very easy, all right? All we have to do is, the first thing is define your module. So in our example, we'll keep it short and simple, but we're going to have a Py file that we create, all right? And it's Python 30 modules 2 synchronicity. And look up here, what's the name? It's Python 29 modules 1, all right? I just have to remember that. And I'm importing Python 30 modules 2 synchronicity, which is this file, okay? So this is sort of this is the file where I'm importing and where I'll be calling the resources. And then this is the module that I wrote where the resources are, okay? And it's just very simple. We have one function here. What time is it? The time is 444. We have a couple of variables here. But again, it's a completely separate file. To use it, I just need to import it. I use the keyword import, and then the name of the file, if you look up here, the name of the file is Python 30 modules to synchronicity. All right, that's all I have to do. If I do that, I can show, in this case, I'm just showing the directory of Python 30 modules to synchronicity. And then if I want to call a function, look, here's the name of the file. It's my module. And here's the function. What time is it? The time is 444. Okay? Just prints out one statement. That's one way of doing it. Another way of doing it, I can use the keyword import. I can call the module, and then you can create an instance of it. I could just call it S or sync or whatever I want to call it. It was synchronicity, so in this case I called it sync bit. And if I do that, I can just access all of the items here, whether it be a function, whether it be the variable names with the dot operator. All right, so see how I did that with name, age, and class? Well, tname, tage, and tclass they take their values from the module. So let's see how this works. All right, we will give us a bit of real estate here. And I'm going to hit F5, we'll call it. Okay, import entire module and list all members with dir, right? So dir, these are all the data members that I defined in the module, the age, the class, the name, and then the function, what time is it? See? Here they all are. This is my module, and then over here in this file, this is where I'm importing that module. And that's all we've, the dir method just reveals all of that in addition to we have all of these built-in Python items that we can make use of, which we'll look at in later videos, but a call a function from an imported module. All right, so again, just the module name here, the dot operator, and what time is it? And look, the time is 444. It calls this method, this function, from our external module, okay? Now let's try it the other way where we import it and then set it to an instance. So we're importing our external module that we created as sync. We could call that anything, banana, X, Y, whatever. But now we can use that as sort of an abbreviated instance of our module to access the functions and the data inside of it. So look, now that we have an instance, sync what time is it, calls what time is it, and what happens? The time is 444, all right? Then we're taking our variables, sync the name, sync the age, sync the class. Well, let's look over an external module. Look, the name, the age, the class. Oh, and that should be actually 53 now. But, so you see how this works? Pretty cool, huh? Not too complicated. And again, maybe the usefulness of it isn't apparent in such a small example project. But imagine you've got thousands upon thousands of lines of code. You can make your project a lot easier to manage if you were to organize it not just in functions, not just in classes, but also in separate modules. And this is how you would do that in Python. They don't make it hard at all. Okay, so here's our values down here, anonymous, class, unicorn. Now, let's clear the console and look at another example. And then we'll be done with modules. And this might be the shortest Python video we've ever made. All right, so let's pull this one up and this one up. Here's a more realistic example of a need for a module, right? So in one of my projects, it was an RPG. It's about 6,600 lines of code. And I have a class inheritance hierarchy. And for GitHub and display purposes, I put it all in one file. But it would be better to break it up into modules. And so one of the things that would be good to put into modules would be my class inheritance hierarchy. Okay, so I had game entity, that was my base class, my abstract data type, my parent class, and it had all of these functions and methods here, and I had um, chaos agent and antagonist. Antagonist inherits from game entity. Chaos agent inherits from antagonist. I had pony, which inherits from game entity. Alicorn inherits from pony. Unicorn inherits from pony. Pegasus inherits from pony. Princess inherits from alicorn. Right? NPC inherits from game entity. I had all these classes defined, these class definitions, right? And they took up a fair amount of code. 800, almost 900 lines of code. But that would be an example of I could break this up into a separate external module. And if I wanted to, I could even put each separate class in its own separate external module. But I don't want to do that. I don't want to go that far. But it would be nice to have them all organized in one external module, all my class definitions. So that's what we'll do. Here I have a function, test function, just to show how to call it. And here I have a test variable just to show how to do that. So this is our external module file, Python 31 modules 3 class hierarchy. Now let's go to here's the Py file where we import and make use of our external module. Okay, so I'm going to here, actually, let's go ahead and call our test function first and then, all right. So I'm going to import. This is the name of my external module, right? That's this file over here. It's got my inheritance hierarchy, all my class definitions, as well as the test function and the test variable. I'm going to come over here, and then over here, I'm going to create an instance hierarchy, all right? So import Python 31 modules 3 class hierarchy as hierarchy. That's just my instance name, hierarchy, okay? It's a little bit shorter, a little bit abbreviated. And then I'm just going to print hierarchy and test function. So we're going to test it. Can we invoke a method, a global method, not from our classes, inside that external module that we've defined? Okay. And then here, second, I'm going to say, okay, well, I'm going to print the value of this variable over here in the global namespace, test variable, curly solali. All right, that's our external module. Go back to our importing Py file. So testing the test function, testing the variable. Now, this is how I would get at those classes. If my class hierarchy is in an external module, all I need to do to be able to pull those classes in one at a time and use them is to import them. And in this case, the syntax is a little bit different, but not too different from what we've already done with modules. I would say from the name of my external module minus the .py extension, just the name, okay? And then from that external module, import, and then the class. And I'm doing that with pony and unicorn and alicorn. I need to do that for every single class that I'm going to use or call from that file, from that external module. And once I do that, I can instantiate and use those classes just as if they were all defined in one huge script file with thousands of lines of code. Okay, so look, to prove that we can do this with an external module, once we've imported them, and we've imported our classes defined in our external module, I'm going to create instances of a pony. We'll call her Applejack. And I'm going to call pony stuff. That's a method specific to a pony. And then display entity, that's a method that pony inherits from the game entity class. Okay. And again, we'll take a look at that. Here's game entity. And let's look at display entity. All right, so this is just the base class, the abstract data type. The parent object, it has a method display entity. So anything that inherits from it, that derives from it, can also use display entity. It can inherit and use all that code, all those data members, all those member methods in the ADT, the abstract data type, the parent class. But also pony, scroll way down here. Pony has its own method. Okay, pony stuff. and it just says doing pony stuff. So in the child class and in the parent class, from the external module, I'm just showing that we can use both methods. Next, Rarity, we're going to build a unicorn, okay? And into the constructor, we're just passing her name, her class, and some stats. Again, we can access a unicorn method. Let's go look at a unicorn method here. Okay, so unicorn displays a unicorn's special abilities. And then in addition to that, we can call display entity because look, in our external module and our class definition, unicorn inherits from pony, pony inherits from game entity, and game entity has the method, the function display entity. So all of our code, we can inherit upwards towards the parent and the grandparent and get the benefit of all that code that's already been defined. No need to reinvent the wheel or needlessly type more code than would be required. We're doing the same thing with alicorn, okay? We're going to display alicorn. That's a method specific to alicorn. You know, display alicorn, alicorn special abilities. And then we're going to call the parent class method display entity. But look, see how neat and tidy our code is? Not very much code in this file at all. We've shifted our code into our external module. So we've sort of hidden away in a nice, neat, organized fashion all of our class hierarchy definition code. So again, modules, it's just a third way to modularize your code. And that makes it more useful, easier to use, easier to collaborate and work on projects together. Again, look at the open source community and some of the amazing projects out there that just hundreds and even thousands of developers have contributed to. If they didn't practice modular code, that wouldn't really be possible. And not just open source, even closed source projects. Odds are you're not going to be the only developer. You're going to be working with dozens upon dozens of developers on a team. And so if you're going to collaborate and share the workload, 12 people can do a whole lot more than one person. But you have to have some tools to get organized. You have to write very modular code, neat code, documented code. You have to have version control, versioning. We'll talk about that in later videos. But these are just 3 tools now that we've gone over in this series of videos, right? Functions, classes, and now modules, okay? Very, very important as our projects get bigger. And as we want to collaborate and let others, stand on our shoulders. And again, there's nothing more wonderful than the feeling, you write something, you create something, and then years later, you notice that like several people took your idea and they ran with it, and they grew it and expanded upon that idea, and they added a lot of additional functionality, and the next thing you know, that very simple little widget that you created, maybe years ago, becomes a component or a tool in someone else's creation that's just doing wonderful things. And it's like, it just kind of gives you the feeling that there's meaning and purpose in life, that there's a big picture, that somehow we can all connect our brains, our minds into a larger whole and work together for the greater good. I know that maybe that sounds corny, but it gives you a sense of meaning, purpose, accomplishment, like you're not alone. And when you can work on a project together with someone, and these techniques for modularizing code, functions, classes, and modules, they're going to help you do that. So all my schmacking behind this is supposed to be a short video, right? So let's go back to our file. Here's our file where we're calling our external module. Let's see what happens when we run it, okay? I'll hit F5. Okay, so look, let me scroll up here. Successfully called test function from external module. All right, well, where does that come from? Let's scroll back up to the top here. All right, that's our test function. Successfully called test function from external module. All right, so we pulled that function from our external module. And in this case, using our instance name, we scroll up here as hierarchy. And that's where we said hierarchy dot test function with the dot operator. Okay, and then what happened next? Value of test variable from external module is Carly Solali. Well, again, let's go back to our external module. Here's test variable. So we just use the instance, which we imported as and defined as hierarchy up here, and we used the dot operator, and that's how we got the value of our test variable. Now, what about our classes that we imported as pony, unicorn, and alicorn from our external module that has all of our class definitions in it now? Well, look, we built Applejack, Rarity, and Twilight. Let's see what happened. We successfully built a pony. We called the pony method, doing pony stuff from the external module. Then we went up the inheritance hierarchy all the way up to the grandparent, or the parent, and we called the display entity member method, and we were able to display the data members, that we set, that we, and in this py file, we're able to pass in our variables or attributes to the constructor, to our external module, and then we were able to display it and call it back. Same thing with unicorn, right? We used our built-in unicorn function from our unicorn class in our external module, but that went up the inheritance hierarchy and called the display entity method and displayed the data members, the attributes that we passed in. And here we build our unicorn module, and look, we're able to call the unicorn, building a alicorn. Ooh, I got an error there. Let me go fix that. Let me go fix that in the constructor. I'll leave this in so you can see some editing here. But, let's see, alicorn. Yeah. Truth in advertising. All right, so let's run this again. Just don't want it to be confusing, babe. Okay, so building an alicorn. And we're instantiating an alicorn right here, okay? And we're calling an alicorn method, and then we're going up the inheritance hierarchy and calling the grandparent method display entity to display the stats here, all right, for Twilight Sparkle. But just to give you two examples of how to, write code in an external module. It's just another py file. Save it as a .py file, and then you use the keyword import. And with import, you can import it as an instance. You can import the entire, external module if you like, and then and also if you're going to use a class, it would be from the external module, the keyword import, and then the class name. Well, thanks for watching. I'll see you in the next video.